Great. So the methods of interpolation, if you even look at this one, this diagram, you can see that the colors are indicating that there are values everywhere, because everywhere within this, the extent of this box, there is a shade of green. Is that okay? And this is the legend to it, the key to this representation. We see the original sample values versus the actual raster that has been generated. Okay, now the methods used are inverse distance weighted, natural neighbors, spline, trends, surfaces are used to determine the new values. So, okay, for inverse distance weighted, we make use of the principle that near points should contribute more than distant points. Is that okay? All right, now an example of the surface generated with IDW, inverse distance weighted, is this. And in IDW, as opposed to your cumulated weighted averages, we make use of an inverse of your weight, and the weight is the distance. So 1 over the weight, okay, 1 over weight, where weight is the distance of any point from the point of known value. So interpolation is all about determining the value of an unknown point. In the case of student averages at the tertiary level, we multiply the weight by the value. But in the case of IDW, we invert it. So weights normally we multiply, but we're not going to do that. This is an example of natural neighbors, except that here the way the values are calculated, computed, make use of what we call the delineate triangulation. All right, but then the result is slightly different, even though we still recognize that there are some hilly areas down south. Are you okay? Spline can also be used to, we can fit a spline to a surface. Okay, and that's another way of interpolating. So this is a spline surface, and we can have trend surface. So this is a trend surface example. All right, over here we are creating a density surface. So we have the points, then we have the raster version. So literally we are rasterizing. We are actually moving from points to raster. It's called rasterization, but obviously the surface you get is just an interpolated value. All right, so here we have lines, and then we have the surface is some kind of pink scale, if there's anything like a pink scale. All right, so from white to deep, it's orange. Well, I'm colorblind, isn't it? No, I'm not. Okay, so there you go. So density tools in software can allow us to find how many or certain that per unit area. Okay, density is always like that. You need to find how many you have within a certain area. All right, density. The formula for density in physics. We don't want to go there. All right, think about it to help you. All right, great. You can have examples. You know, you can think outside the box. Yes, we'll ignore this topo thingy. Yeah. The 10, have we talked about 10 triangulated irregular network surface creation tools? I think, yeah, they allow us to create a 10. So let's see if we can have a 10. I'm skipping a lot of these things. Okay, let's talk about terrain surfaces. So terrain surfaces, we can have what we call the slope. We can have the aspects. Are you okay? All right, slope, aspects, and yeah, basically that's that. You can have a hillshade. All right, now normally we generate these surfaces from what we call a digital elevation model. A digital elevation model is a raster in which the values are represent elevation. Okay, so this is an elevation raster. This is what we call an elevation raster. If you have, I think our tutorial that we'll do, we'll make use of these things, so you will get to know probably exactly what we mean. So don't worry about it if you don't get it now. Okay, so you can have a slope. In the slope 2 calculates the maximum rate of change from cell to its neighbors. So remember, when we had a surface of distance to bar stops, remember that one? Every cell will have a value that represents Sadiq is back, but I don't know. He's not there. He should not even be kidding me. Sadiq. I'll show him. Anyway, so the aspects shows you the direction of the slope. Okay, so the point being made here is that if I want to figure out, okay, where you are facing, okay, let's look at Asamoah's house on the West Hills. Okay. Okay. Or let's see all the houses on McCarthy Hill. You can see that they are on the slope, right? Straight away, they can't see the other side of the slope. Okay. So that is an application. That's an application of the aspects. The aspect calculates the direction in which the plane fitted to the slope faces for each cell. Okay. So you can get, when you look at the values for the slope, they are like bearings. So because you want to know, is the surface facing north or is facing west? Now, if the surface is facing east, what does it mean? Patrick, what does it mean to face? If your house is facing east, what's the problem? Patrick, see, he's gone. Eh? Ah la la, ha 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 ha. Kofi, Isaiah.
Yeah, I am not going to. It is my screen.
It is your
you
screen.
say if my house is facing east, what will I face?
What would it mean for you?
Yeah, I will be. It means that I will be having sun effect because
Thank you
the
very
sun
much.
will be.
Every time you wake up, the sun will be right in your. Continue recording. Okay. Okay, so that is basically it. So for it has a lot of applications. You have to, like I keep saying, it's up to people to have a group discussion. I've asked questions about slope and aspects several times. So it will be up to you as a class to look at it. What are some of the application areas? Then you can know what you can have security implications. If your house faces a certain direction, there's security implications. I can create a scenario so we to figure out and say that, okay, I have to generate a slope, an aspect surface, an aspect raster. Are you okay? So here, this is the hill shade. Hill shade shows the intensity of lighting on the surface. Given a light source at a particular location, it can model which parts of the surface will be shadowed. But okay, so at the end of the day, you tend to look as if it looks like a solid. Hill shades always look at you're looking at a solid, as if it's a mountain, yeah, a hilly district, eh? Like you can actually move on top and stuff. Like if you've been watching cartoons, that's how they look like. Okay, so take note of that. Okay, let's keep the curvature tools. Let's go for visibility tools. So this is probably the last one we're talking about. This is what we also call the line of sight analysis, view shed analysis. Are you okay? View shed analysis. So let me tell you what that is. That is about which areas can be seen by an observer. Are you okay? That's what it's about. Which places can be seen by an observer. Okay. So when you look at it, I'm trying to record again. Okay, so that is why I went backwards. Visibility tools. What's your understanding of visibility tools? The president is going to Kumasi, he's going to Mensha. Are you okay? You are a little boy, you get there with your father and you realize that there are soldiers on top of the building. Okay, why are the soldiers on top of the building? So that they can have a view, a certain view that is far better than all of you down there, so that in case someone makes a move, then they can take the person out. Is that okay? Now the view of the soldiers at the top is their view shed. Every place where they can see, you can paint it, and that becomes the view shed. Okay, so we have visibility tools. There are lots. Some of the things you are looking at here, they are all related to that. But when it comes to view shed itself, okay, which is of course, you can't see it here. Viewshed. Let me go to Google and get an image for you. I want our focus to be on viewshed. We can also have watershed. So with the watershed, there are places that you can see. Okay, so in viewshed, the observer is actually, at a certain point, and then you have the actual point of interest. So the observer is there, he's looking at the terrain. What can he see? Are you okay? All right. Now you can have application of that to telecommunication. When there is a signal is transmitted from the transmitter to your phone, are you okay? It can be blocked. Are you okay? How can it be blocked? If there is a tall building in front, you may
with a question asking if what I would have talked about this semester, but that time my gadget were disturbing me. I don't know which to answer. I couldn't even talk anything. So you started the class.
I didn't get all that you said. Say it again. Say it again.
Yeah. I said before you started the class, you were talking about the mid-semester exams.
Right.
Yeah. And you were